Welcome to homework.
So for part A, let's just draw a diagram. So here would be f sub 1. This would be our angle theta. Here would be f sub 2. And then this right here, this vector right here, would simply be our net force. So we can say that for part A, rather, the force net in the x direction would be equal to negative force of 1. It is going to the left, so we'll say it's negative. And this will be negative 10.2 newtons. And then force net sub y, this would be equal to negative force sub 2. And this is equaling negative 16.0 newtons. Now, in order to find the magnitude of the force net, this would be equal to the square root of the sum of the squares. So negative 10.2 squared plus negative 16.0 squared, all to the 1/2 power. And we find that the magnitude of the net force is going to be 19.0 newtons. Now let's find the direction. So here we can say that the direction theta would be arctan of the y component, negative 16.0, divided by the x component, negative 10.2. This is going to equal 57.5 degrees, and this would be 57.5 degrees below negative x-axis. So we can say that the acceleration would then be equal to the net force divided by the mass. So this would be 19.0 newtons divided by the mass of 18.5 kilograms. And we have an acceleration of 1.03 meters per second squared. Again, 57.5 degrees below the negative x-axis. Now, for part B, let's draw again a quick diagram. This would be our x-axis, this would be our y-axis, and here would be our force sub 1. This would be a 30-degree angle. This would be our force net. This would be our angle theta. And then going straight up, let's actually extend this. Going straight up would be our force sub 2. And this would be how the vectors are related. Okay, and at this point, we can say that force sub net in the x direction would be equal to the force sub 1 times cosine of 30 degrees. And so this is going to equal 8.833 newtons. The force net in the y direction would actually be equal to force sub 2 minus force sub 1 sine of 30 degrees. And this is giving us 10.9 newtons. So again, we do the exact same analysis to find the magnitude of the net force. This would be equal to 8.833 squared plus 10.9 squared, all to the 1/2 power. We can say that this is going to be equal to 14.0 newtons. And so we can say that theta would be equal to, again, arctan of the y component divided by the x component, so 10.9 divided by 8.833. And we have that theta is going to be equal to 51 degrees above positive x-axis. And then the acceleration would simply be equal to the force net divided by the mass. So this would be 14.0 newtons divided by the mass of, again, 18.5 kilograms. And this is giving us 0.758 meters per second squared. So that would be our acceleration. This would be our direction here, and this would be our magnitude of the net force. That is the end of the solution. Thank you for watching.